In 2013, a neuroscientist named Jimo Borjigin was studying cardiac arrest in rats at the University of Michigan. She wasn't looking for anything strange. She was just watching brain activity as the rats' hearts stopped. What she saw didn't make sense. In the seconds after the heart stopped beating, the rats' brains didn't go quiet. They got louder. A massive surge of gamma wave activity tore through the brain, far stronger than anything recorded while the animals were awake. Gamma waves aren't random noise. They're the specific frequency your brain uses when it's binding separate pieces of information into one experience. Recognizing a face, recalling a memory, becoming consciously aware of something at all. For decades, scientists treated near-death experiences as unreliable stories. People claiming they saw a light, relived their lives, felt outside their own bodies. There was no machine that could confirm or deny any of it. Borjigin's rats were the first hint that something measurable was actually happening. But rats aren't people, and a lab study isn't a real death. Scientists needed something they could never ethically create on purpose. They needed to be already watching a human brain at the exact moment a real heart stopped. In 2022, they got it by accident. An 87-year-old man in Canada was being monitored for epilepsy. Electrodes were already glued to his scalp, recording every flicker of his brain around the clock. Then, without warning, he had a massive heart attack and died while the machine was still running. Nobody planned this, nobody could have, but for the first time, scientists had a continuous second-by-second recording of a human brain crossing from being alive to being dead. A team led by Raul Vicente at the University of Tartu pulled the recording apart afterward. In the 30 seconds before his heart stopped and the 30 seconds after, his brain produced a sustained surge of the exact same gamma rhythms Borjigin had seen in the rats. Here's the part that should bother you. Those same gamma patterns in that exact frequency range show up in living, healthy brains during one specific activity, pulling up a memory and replaying it. Not imagining something new, recalling something that already happened. The dying brain wasn't shutting down. It was doing something that looked almost identical to remembering. Nobody can prove what, if anything, that man was experiencing. He couldn't tell anyone afterward. There is no way to climb inside someone else's dying brain and ask what it was like in there. That gap may never close. But the timing lines up with something people have been describing for centuries in cultures that never spoke to each other, who never read the same texts, who had no reason to copy the story from one another. A life review. Old memories, often from childhood, surfacing rapidly and vividly, sometimes compressed into what feels like a few seconds. For most of history, that story got filed away as a comforting myth, something grieving people told themselves. Now there's a physical mechanism that could actually produce it. A flood of memory-binding brain activity switching on in the last moments anyone has ever been able to measure. This isn't unique to one unlucky patient. Borjigin's later work scanning other dying patients in hospital found the same gamma surge pattern in roughly a third of them. Not everyone, but enough that it isn't a fluke. It also isn't the only large study pointing the same direction. In 2001, a Dutch cardiologist named Pim van Lommel published a 10-year study in The Lancet tracking 344 patients who had been resuscitated after cardiac arrest. About 18% of them reported some form of vivid experience during the window when their hearts weren't beating and, by every standard measurement available, their brains should have been offline. Many describe the same elements showing up again and again. A rapid review of personal memories. A sense of clarity sharper than ordinary waking thought. None of them could have compared notes beforehand. Most had never spoken to anyone else who'd been through it. None of this is a new idea dressed up in new equipment. The Tibetan Book of the Dead, written more than 1,000 years ago, describes consciousness passing through a sequence of vivid inner experiences in the moments after the body fails. Buddhist monks in Nepal and Hindu traditions in India describe nearly identical stages, despite no contact between the two regions when these texts were first written. None of them had an EEG. None of them had a word for gamma waves. They were describing the same pattern from the inside, centuries before anyone could measure it from the outside. So, if you're one of the ones whose brain does this, here's roughly what the evidence suggests is happening in your final 30 seconds. Oxygen drops. Your brain, starved of fuel, doesn't fade out evenly. Instead, several regions linked to memory and self-awareness briefly surge into a level of coordinated activity beyond what they manage while you're alive and well. For a few seconds, the parts of your brain responsible for stitching together a you who has a past may be working harder than they ever have. Then the activity stops. Completely. Every measurement so far shows it doesn't restart on its own. A cardiologist named Sam Parnia has spent 2 decades interviewing people who were clinically dead and later resuscitated. Many describe a strange, lucid clarity, a sense of watching events unfold, a return to memories they hadn't thought about in years. He doesn't claim to know what it means. He just keeps finding the same description, again and again from people who never spoke to each other. Maybe it's the last desperate flicker of a machine running out of power, producing something that only looks meaningful from the outside, the way a screen flashes random color right before it switches off for good. Or maybe the brain saves its most coordinated, most vivid activity for the very end, on purpose, the same way it does for anything it's about to lose for good. Nobody currently knows which one is true. Both explanations fit the same data. What we do know is this: the moment you've spent your whole life dreading as a flat, silent shutdown may actually be one of the most electrically active moments your brain ever produces. Louder, by some measurements, than an ordinary afternoon spent scrolling your phone or sitting in traffic. You will never get a confirmed answer about what it's like to be inside that surge. Nobody who has ever been there could come back and explain it in a way the rest of us could fully trust. But think about what it would mean if this turns out to be true for you too. Not a slow fade into nothing, not static. A final, full-volume pass through the moments that actually made up a life, run by the same machinery that built those moments the first time around. Which raises an odd question. If you're about to die anyway, why would your brain spend its very last reserves of energy on something so specific? Evolution doesn't usually keep features that serve no purpose. A dying brain gains nothing by reviewing old memories. There's no future left to apply the lesson to. One possibility is that this isn't a function at all, just an accident, the brain's tightly wired memory circuits firing themselves into overdrive as their oxygen supply collapses, the same way a machine can spike before it cuts out completely. Another possibility, harder to test and impossible to prove, is that the circuitry simply never evolved an off switch for this particular response, because for almost all of human history, there was no surviving the moment afterward to ask why. It wouldn't make dying painless. It wouldn't make losing someone hurt less. But it would mean the last thing a brain reaches for when everything else is being switched off isn't fear. It's memory. The version of you that mattered enough to keep, replayed one final time by the only audience who ever fully had it. So close your eyes again. That memory you pictured at the start. Hold on to it a little tighter than you usually would. Apparently, your brain already plans to. A note on sourcing. The Borjigan 2013 rat study, the 2022 Vicente/Tartu human EEG case, and the von Lommel 2001 Lancet study are all real published research. Worth a quick verification pass before production, since exact figures in real studies can be revised or contested.